Hello, I'm Mrs. J. We're going to continue with 6.1 and 6.2, and these first two we're solving for x. When you're solving for x, you can rewrite it. Remember, when there's no base, it's base 10. So start with your base and loop around. 10 to the 4th equals x. 10 to the 4th is 10,000, so x is 10,000. So get the log by itself and then rewrite it. Here we can combine these two logs because they have the same base. When we're adding, they become a multiplication. So it's the log of 3x, and the base is 2, equals 5. Now that we have one log, we can rewrite it. Start with your base. 2 to the 5th equals 3x. 2 to the 5th, 2 times 2 is 4, 8, 16, 32 equals 3x, and divide by 3. Now what you do need to make sure when you get your answer, if you plug it back in, it has to be a number greater than 0. And if we plug 10,000 in, it's greater than 0. If we plug 32/3 in, it's greater than 0. So you do need to check that. Let's go this way. I don't know why some of these are light. Okay, it's the log 6x plus 1 minus the log 3x plus 10 equals 0. Now there's two ways you can do this. One, you can combine these two, or you could bring this to the other side, because a log is 1 to 1, and so if the logs have to be equal, what you're taking the log of needs to be equal. If you have the log of A equal to the log of B, then A has to equal B. So we could bring this to the other side. So for these to be equal, then 6x plus 1 has to equal 3x plus 10. Bring the 3 over and get 3x plus 1 equals 10. Subtract the 1 and divide. So we get 3. Double check that you're not getting 0 or a negative number. 6 times 3 is 18 plus 1 is positive. 3 times 3 is 9 plus 10 is positive. We just want to make sure it's not 0 or negative. So this is a good answer. How about this one? Okay, there's a couple ways you can go with this. First, get the part that has the exponent by itself. So we'll divide by the 100. Now, when you have a variable in the exponent, what you can do is either take the log of both sides or the natural log. I like to use natural log, but they'll both give you the same answer. So I would take the natural log of both sides. Because then, remember, log and natural log, we can bring that exponent down in front. So anytime your variable's in the exponent, you're probably going to have to use that. So we have t and the natural log of 1.5 equals the natural log of 20. And then divide by that natural log of 1.5. And t equals, and then we would plug that into our calculator. If they want the exact value, then you type this in. If they want the decimal, then we type the natural log of 20, close parenthesis, divided by the natural log of 1.5, close parenthesis. And we get 7.39. How about this one? Natural log of 1 over e to the 5th. Now maybe if I shut this, it'll look better. Ah, that did help a little. Okay, a couple ways we can do this. We can bring the e up first, or you can break it into 2 because the natural log of 1, and then the bottom is divided, so you subtract the natural log of e to the 5th. The natural log of 1 is 0, minus, these are inverses and leave 5, which leaves us a negative 5. If we would have brought it up first, the natural log of e to the negative 5, and then remember these are inverses, so it still leaves a negative 5. Either way, same answer. On this one, we want to contract it to 1 natural log. Well, these two get multiplied because they're added. This one would get it's subtracted, it would get divided. But before we can do that, we need to move the 4 back up. So we have the natural log of x plus the natural log of y minus the natural log of x plus 2 to the 4th. Then we can combine them. The natural log x times y divided by x plus 2 to the 4th. So the minus makes it a division. Okay, another one we're trying to solve. E to the x plus 2 equals 20. To get rid of the e, we take the natural log. Cancels and leaves x plus 2 equal to the natural log of 20. Subtract the 2. What you need to be careful when you enter this one, close the parenthesis before you subtract 2. So we have the natural log of 20 minus 2. 996. One more. This one is compounded interest. 5,000 doubles to 10,000 in 7 years. What is the interest if compounded continuously? Compounded continuously is a equals PE to the RT. P is your starting amount and A is the ending amount. So we're ending with 10,000 because we're doubling our money. We're starting with 5,000. Interest rate is what we are looking for, and time was 7 years. So I'm going to write it 7R. Get E by itself, divide by the 5,000, which gives us 2 equal to e to the 7R. To get rid of e, take the natural log. And then to get rid of the 7, divide. And that will give us r equal to the natural log of 2 divided by 7. 0.09902. Now, depending on what you have to round it to, keep quite a few, because r is a rate. To rate the percent, you need to multiply it by 100. So it's 9.902, depending on what you have to go to, percent. That's everything from that section.